section. I think I'll finish it today and touch on this section for tomorrow because the rest of today is pretty easy too. Are y'all sure? Do 35? 35 and 37? They're just saying that because you don't want me to feel bad for not having a problem to work. From 0 to pi over 3, 2 secant squared theta d theta. What's the antiderivative of secant squared? Just tan. The 2 can come outside. That's one of those properties. So 2 tangent theta evaluated from 0 to pi over 3. Tangent of pi over 3 minus tangent of 0. What's the tangent of pi over 3? Square root of 3. What's the tangent of 0? So 2 root 3. Y'all said another one. 37. 37. The integral from pi over 4 to 3 pi over 4 cosecant x cotangent x dx. Antiderivative there would be negative cosecant x evaluated from pi over 4 to 3 pi over 4, which would be negative cosecant 3 pi over 4 minus negative cosecant pi over 4. Cosecant is 1 over sine, so what's the sine of 3 pi over 4? So if I flip that, so square root of 2 over 2 flipped would be 2 over square root of 2 multiplied by root 2 square root of 2, right? This is plus now. What's the sine at pi over 4? Same thing. Flip it. Yep. Anything else? Everybody good? Well then, let's see. I want to show you a couple more things with this, and then we'll do trapezoid rule. Area first. Area. Let's say area under the curve, part like 100. Doing this. I'm looking. Shall we do hard or should we do easy? Start with hard. This is 54. You have this graph. Y equals sine x pi over 6. 5 pi over 6. Henry asked for this one. I'm just kidding. Oops, we don't even want that. Find the area of the shaded region. Any thoughts or ideas? Henry, your eye is really red. Yeah. Does it hurt? Yeah. No, it's just one eye. If he did, he got some wonky stuff because it's just one eye. It's not good. Does it hurt? Does it itch? Fine. Look at Caroline. She wants to see it. It's like the inside of it. No, like that. long as it feels fine, I suppose. Yeah, it's the lack of calculus causing your eyes to be red. All right. Ideas, thoughts. What can I do? How can I find the area of the shaded region? Is it what? Yeah, because sine x goes up to 1. What'd you say, Hope? Okay, area of the rectangle. So area of the rectangle is going to give me this green part. Well, we can at least do that because we know how to do that. Length times width. So what is the length across from pi over 6 to 5 pi over 6? 4 pi over 6 or 2 pi over 3. And I need to multiply that by the height. What's the height of that rectangle? How do I find that height? You plug it into the equation. That's right. So what's the sine of pi over 6? 1/2. So times 1/2. So the area of this rectangle, pi over 3, agree or disagree? I agree because that's right. Thank you. Pi over 3. That's just this area. That is not the area we were asked to find, however. Go ahead. Okay, so you're close, but not quite, because it's not quite a semicircle, because look at where I want. I want from here to here, and I just want that top part. Why do you want the height of that area, though? It's a little semicircle. Integrals give me the area under the curve, right? So why don't I just do the area, the integral from here to here? You do have to do the what? The first. Yes, because that's going to give you, this is going to give you all of this, right? And then I would subtract out the rectangle. Does that make sense? All right, so what's the antiderivative of sine? Negative cosine. There you go. Good job, Drew. From pi over 6 to 5 pi over 6. Negative cosine of 5 pi over 6 minus negative cosine pi over 6. All right, what's the cosine of 5 pi over 6? Negative root 3 over 2. So I'm going to make it positive because it's negative out front anyway. And to that, I'm going to add the cosine of pi over 6. What is that one? Pi over 6, root 3 over 2. So I get half of a square root of 3 plus half of a square root of 3 gives me a whole square root of 3 minus that area to start with. So the area, I'm going to call it the purple area, is going to be square root of 3 minus pi over 3. That makes sense? Do I? That's the hardest one as far as shapes, I think. 53 gives you a shape that looks like this, and I'm not going to do it for you, but we'll just talk through. You need me to go back? Oh. This is pi. It does. And this is y equals 1 plus cosine x. This is y equals 2. This is x equals pi. And the shaded region is here. How would you find that? Yes, y'all right. Did y'all hear what they said? Did y'all understand? They were kind of okay. Area of the rectangle would be all of this, right? From that, I would subtract, because I want this shaded region and I've got the whole thing, I need to find this white part right here to subtract out of the rectangle to leave the red. So to do that, that would be the integral from 0 to pi of 1 plus cosine x. Yes. How about this? Lemons are harvested from a certain orchard at a rate modeled by. I just didn't finish solving it for you. You'll have to go back and solve it. But yeah. Let me go back. At a rate modeled by bushels per hour. L 41. For 0 to 10 hours, how many bushels of lemon have been harvested over the time period 0 to 10? So if L of t is bushels per hour and you want to know total bushels after 10 hours, what would you do? This is a rate. Well, if I plug 10 in for t, I get 20 times, I get 200 minus 100, I get 100. So you're saying there's 100 bushels after. I say if you're doing this, 20 times 10 minus 10 squared, and we said that's 100, you're still in bushels per hour. You haven't changed it's still the same rate. The units are the same. You just plugged in 10 for t. How would you find how many bushels? If I've got a rate, I've got to do antiderivative. You're exactly right. So if I want to go from rate back down to bushels, I'm going to need to go from 0 to 10 of my function dt, and this would give me the number of bushels because this is going backwards, right? This is already the derivative. I need to do the antiderivative, which is the integral from 0 to 10. Does that make sense to you? Maybe, maybe not. A little bit. So if I want to go backwards, I'm going to use the integral, which is the antiderivative. That's all I'm doing. And it'll tell me how many bushels or how many things. So if you start with a rate, you know you need to go backwards. Yep. Water is pumped into a tank at a rate of gallons per hour between 0 and 3 hours. What's the total amount of water added between 0 and 3 hours? How would you do that? How many gallons were added between 0 and 3 hours? There's your rate. If it's going in at a rate of this per hour, then my gallons in the first 3 hours would be from 0 to 3 gallons. Does that make sense? Yeah, sure. It takes the rate part off, yes. It's going to change it from that rate to. I'll make sure I've covered everything here I want to cover. you get something that looks like this. When you have area under the curve, under the x-axis, the integral of that is negative. Because if you think, I got to get back up to the x-axis. So here, the integral from 8 to 10, and I don't know, we'll just call this f of x is going to be negative. That's this area here. This area, 0 to 8, is going to be positive. Now I'm saying area, but really it depends on what the question is asking me, because if they're asking me to evaluate an integral, it can be negative. But if they're asking me total area is always positive. Because you can't have negative area, right? Right. So the integral here is negative, but if I'm asked for area, then this would be, so the area here would be positive. Area is positive, but the integral itself could be negative. So it depends on what the question is asking you. If it asks you for total area, you want to make sure you do absolute value. But if it just asks you to evaluate an integral, you have to take the negative into account. If you put this on your calculator, it's going to give you the negative area there for that interval. All right, I think that's it before we do. Y'all need a break in between before we do trapezoid? It's just 8:30. I also have to put the trapezoid rule on y'all's calculator. A lot of them, but you have to do in my hand first, and then let's take a break at the end. We start skipping a lot after this. Here, there, and yonder. Just picking up AB topics. I'd rather just pick up AB topics and spend time to review than I would do BC topics. All right. Here's what trapezoid rule does. Trapezoid rule is nothing more than we take the area under the curve. Remember, we had that area under the curve before, and we use these rectangles to approximate. Say this is my curve divided into however many sub-intervals I have. I feel like those are even. Now, instead of doing rectangles, what I'm going to do is take each endpoint, connect them, and make a trapezoid out of them. And so it's a little bit more of an accurate estimation of the area under the curve than simply having, oops, it's terrible. It depends on how the curve is going. It kind of looks a little, but you take the endpoints, you connect them, and then you drop down to your endpoints on your intervals, and that's how you form your trapezoid. Remember, a rectangle is a trapezoid, but a trapezoid is not always a rectangle. For this one, they are, but it would depend on what your graph looked like, right? So if my graph looked something like this, and I wanted the area from, well, let's say I want it from here to here. I guess, yeah, it would be a triangle. Right? No. Here to here. No, it wouldn't. So it just depends on what that end looks like. But your height would be 0 on that one. All right. How do you find the area of a trapezoid? Just a basic trapezoid. How do you find it? We talked about this earlier. 1/2 base 1 plus base 2 times the height. Right? But we said, say that again. You have to do that for every single one, but it's going to be a little bit, it's not going to be as bad as what you think it's going to be. Essentially what it does is it averages left rem and right rem together. If you added left rem and right rem and then divided by 2, that's essentially what it does. So it gives a little more accurate picture. All right, so I'm actually going to rewrite this. I'm going to put the h and the 1/2 together and call it h over 2 base 1 plus base 2. And remember, these are my heights here in terms of my formula. So my height is really my width going across, right? That h, that's going to be my my width that I'm going across, so my b minus a divided by my number of subintervals. Okay, that's going to be my height. Tell me what my width or my width across. And my bases are going to come from the actual equation. So this would be base 1 and this would be base 2, right? And for trapezoid 1, let's just say trap 1, trap. And then this would be trapezoid 2's base 1, trapezoid 2's base 2. You see what I'm saying? How they're very, so there's some overlap here is what I'm getting at. Are y'all okay there? Let's give these points some names and I think it'll make a little more sense. Let's say this is f of 0. We'll just say f of 1. We'll just say these are intervals of 1. I've got 1, 2, 3, 4, 5 trapezoids. Do you agree? All right. The area of this trapezoid, 1/2 or h over 2, and I actually know my h now, but times f of 0 plus f of 1. Area of this trapezoid, h over 2 times f of 1 plus f of 2, right? Y'all see that? Am I way overcomplicating this? I feel like I am. Would you rather me just give you the equation, the formula? Well, I want you to see where it comes from. That's what I'm trying to get to is where this formula that we use comes from. And so if I keep doing this, what I really want you to see is that they're sharing a side here, right? Each one of these trapezoids shares a side, so it's going to be repeated as I go through. So if I want to find the area of the whole thing using the trapezoid rule, say let's see, area, I'm going to do this one plus the next one, and so on, right? Every one of them has this h over 2. Do you agree with that? So really what I could do is I could say, okay, well, this is h over 2 times, take that out of everybody, and look what I have. I have the first point, 2 of the second point, I'll have 2 of the next point. So what I do is I'll keep going. I'll say f of 0, but then I need 2 f of 1s. I need 2 f of 2s. I need 2 f of 3s, and I'm going to keep doing this. But then for that last one, it doesn't share a side with anybody, so it's just going to be f of 5. Does that make sense? Do you see why we need 2 of them in there? Because they share that side, right? So if I go into B1 plus B2 every single time. All right, so essentially, that's your trap rule. Okay, and that's how we're going to use it. That's what we're going to do. So let me show you an example, and then I think it'll make a lot more sense. Let's use the trapezoid rule to estimate the area from 1 to 2, x squared dx, and let's let n be 4. Most of the time, you're going to do the trap rule with a table of values, and it's going to be a lot easier than what this is. But just so you see what's going on. All right, so from 1 to 4, this is just a parabola that opens up, right? 0, 1, 1, and it's going to do something like this. Really exaggerate this. No, this is just an example. I'll do a homework problem next. Yep. This is the area I'm looking for, right? You okay with that? From 1 to 2. If I need 4 sub-intervals between 1 to 2, this is going to give me my height of each trapezoid, right? So my height's going to be 2 minus 1 divided by 4, which would be 1/4. So I start at 1, 1.25, 1.5. I need 4 intervals. I need it split into 4 equal intervals. I made mine way too small too. Sorry. So now to find the area using that trapezoid rule. I'm going to do h over 2, and what's my h? 1/4. So 1/4, I'm going to multiply by a half since it's a fraction instead of dividing by 2. And then times, now here's where I need to find each and every one of these points, right? All right, this is 1, 1. This is 2, 4. This would be 1.25. What's the corresponding y value there? What is that? 1.625? 1.5625. This one would be 1. Oh, it was a quarter? Okay, 1.5. 2.25, then 1. Yeah. So this curve is y equals x squared, so I just plugged each of those x's in. I squared each one. Base 1 is 1. Base 2, which is shared, so I need to do it twice. 2 times 1.5625. Then 2 times 2.25. 2 times 3.0625. And then the last one only once. You start to catch on to the pattern. I just was wanting y'all to understand why. But h over 2, the endpoints you only get once, and then you double all the ones in the middle. Approximately. I don't know. I got 2.344. Actually 4375, but why did I do 20? Oh, because I did it times point. Y'all okay? Just as a double check to see if I've done it right, I could say, okay, well, on my calculator, what is this area? Or even doing antiderivatives, I could calculate that out to see if I got the same thing. If you do it, I think you will see that you get 7/3, which is approximately 2 point. So it's a pretty close estimate. Is it an overestimate or an underestimate? Over. Why do you think that is? What do you think it has to do with? The curve. It's the concavity of the curve. So this is concave what? Up. So make a conjecture about a concave down. It'd be an underestimate. That's exactly right. Sometimes they will ask you something like that. Is this an overestimate or an underestimate and why? Well, it's based on the concavity of the curve. What do you think about trap rule? Besides being Aggie. It's Aggie. It's Aggie. It's a lot easier if you have a table because then you're not calculating anything out. So most of your or some of your stuff is with a table, and then you're just taking the endpoints. All right, I'm gonna stop. I'll shut up and give you your homework. Unless y'all need me to do another example. All right, we're gonna do 41 through 53, but just the odds. That's from the first section, and then we'll do. Let's just do the odds there. I think that's good.